Physiological data, facial recognition. In facial recognition, features are detected, normalized, matrices are created from those features, they're quantized like before we talked about with code, and stored for comparison. When features are detected, it's going to be picked up using a regular camera, and these cameras are everywhere. Closed circuit technology, CCTV, can pick up and potentially recognize individuals by facial recognition software. Government buildings have them. Some schools have them. Police organizations obviously have them in abundance as well. But they're not just going to store a whole picture of a face and call it a day. They're going to interpret that, enhance only the information that's most important, and then store these differences in important information to characterize individuals. A few different ways of doing this are by PCA, Principal Component Analysis, Linear Discriminant Analysis, LDA, and Elastic Bunch Graph Matching, EBGM. For the purposes of the exam, you do not need to remember these three different kinds exactly by name and which they do. But I do want you to remember that there's a couple of different major ways that these technologies use, a couple of different ways that they use to discriminate different features. PCA uses something called eigenfaces to compare faces. This is a technology to render somebody's face like a series of vertices. So like instead of an even curved smooth planes, you break it into these linear chunks basically of triangles and other shapes to create what's otherwise a relatively smooth image. It takes this vertex rendering of people's most important features, so really more like the bold lines in this picture back here, and then superimpose that data over raw faces for manual analysis later on. These images can be superimposed with one another to see if a captured image from one source matches a captured image from another source and deduce if that's the same person. Linear discriminant analysis is similar to this, but they use individual features as points. So instead of mapping out, say, the sides of your eyes and the overall shape between an edge of your eyebrow, the other edge of your eyebrow, the corner of your eye, the outside of your cheek, it'll instead, I'm going to draw a quick and dirty face over here. There's an ear, hairline, eye, nose. Very pretty lady. Okay. You take the points of this person's face, and instead of registering them as vertices, it'll register them as individual points. So like, here's a pupil, here's a pupil, here's the tip of the nose, here's a nostril, furthest forward point of each cheekbone, corner of a lip. And it'll use these points for comparison instead of whole lines. The nice thing with the points is that these are a little bit more simply translated into a numerical code. And you can also get more of these using less data storage. Elastic bunch graph matching examines the relationship of features. So not necessarily mapping out a whole face, but mapping out, you can use just a part of a face and look at the relationship between this corner and the top versus a cheekbone versus the edge here. And instead of just putting lines between them straight up and then just overlapping the lines, it creates ratios of distances to one another and uses those ratios to characterize people instead. So the takeaway is you can either take somebody's otherwise smooth, rounded out face and turn it into a series of lines, which are properly called vertices. To map out important features, you can use dots, basically, or you can use ratios to pick out one person's features versus another person's features. These features are then normalized. Some people have big heads, some people have small heads. Normalization refers to the smoothing out, I suppose. Of unimportant differences to enhance comparison. So my head looks yay big on one picture. It looks quite a bit smaller in a second picture. If you overlay those two pictures, they're two different sizes, so they're not going to match. Normalization refers to the standardization of each of those images so that they can be appropriately overlaid and compared to one another. Matrices are created of facial features, so basically databases and searchable databases, and the facial features are quantized and stored for comparison then at the end. Just like iris scans, just like fingerprints, just like a whole mess of other personalized data, the NGI database has facial recognition features as well, although this is a fairly recent addition. This and iris are both fairly recent additions to the NGI, so it's not as robust as some other stuff like fingerprints. Benefits of facial recognition include it is fast to do. You just snap a picture and voila, you have the potential for facial recognition. It is inexpensive. The software is inexpensive and you don't need a special physical camera to be able to do it. Your cell phone camera works, as you can see, by being able to unlock your phone by holding it up to your face. It can be done en masse. It can be done out of large groups. So you have a crowd of people who are standing outside of a store waiting in line to buy, I don't know, the new Apple phone, whatever the most recent iPhone is. Their CCTV cameras out front can pick out every one of your faces, put it through facial recognition software, potentially. I'm not saying they are doing this, I'm saying they could. And characterize each one of your faces to see if maybe one of you guys were the person who tried to burn down the Apple store down the block. I don't know, that's just made up. The main problem is that it is highly unreliable. Photo resolution can be highly variable, and it's just so easily thrown off. Sunny day, you have a lot of contrast on your face. On a cloudy day, you have less contrast on your face. That can create a different rendering of your features. Are you wearing glasses? Are you wearing a hat? Have you changed your hair? If you never used to wear makeup and then suddenly you do, your cheekbones look like more prominent on a picture, your eyebrows look longer or fuller or just bigger overall, these things can really throw off facial recognition. It is very unreliable. And ultimately, because these matrices are so unreliable inherently, it's still quite subject to human interpretation after the fact.